another episode of STEAM Sundays hosted by the POBots. Today, we'll be diving into how STEM is revolutionizing medicine, in addition, interviewing a special guest. Now, you might have heard of or watched the video of the guy who used Legos to create a prosthetic arm. Pretty cool, right? But what you might not know is that the video is almost 6 years old. So, what has happened since then?
In that time, new and modern tech has taken over the medical field by storm. Whether it's creating 3D printed organs or helping doctors diagnose disease quicker, it's becoming increasingly common in hospitals and care centers all around the globe. However, it's not just large companies or research labs. Students just like you and me can make an impact too.
I'm thrilled to introduce today's special guest, Dr. Lori Heckelman, a 3-time Duke Biomedical Engineering graduate and current lecturer in the Discipline of Biomedical Engineering at Columbia University, who I've had the pleasure to work under last summer.
Before we start the actual interview, why don't you tell us a little bit about yourself and your passions?
Thank you so much for having me. As you mentioned, I'm a lecturer in the Discipline of Biomedical Engineering at Columbia. I'm also the undergraduate chair, and I've been in these roles. I started as a lecturer in summer of 2022, and then just this past summer, I became the undergraduate chair.
As we've all seen, STEM is revolutionizing healthcare in amazing ways. From your perspective, what is the most exciting recent development in biomedical engineering, and what is its impact on health and medicine as a whole?
I think there's a lot of things going on. I think one of the things that immediately comes to mind is there's a startup company called EpiBone that came up out of one of the Columbia bioengineering labs, and they are actually engineering bones. They're growing people's bones out of their own cells so that you could have like replacement parts of your body, right? So things for your jaw, things for different parts of the body that you can like grow custom bones, so we can avoid metal implants and stuff like that. There's also just like really cool medical devices out there, like heart monitors that are completely wireless and have batteries that last multiple weeks so that cardiologists can monitor the activity. I think that we're in a really cool phase of biomedical engineering and science advancement.
Mm-hmm. So where do you kind of see it, like biomedical engineering as a whole, these developments in the next 5 to 10 years? Like, do you think it's going to start like actually being used like commercially in hospitals? Things like how you said that company who was the startup engineering those cells into bones?
Yeah, I mean that's already past the clinical trial phase, and they're putting this into humans. So I think we're really at the very beginning of where this can go, and I'm really excited to see where it goes and how it can really change people's lives.
Mm-hmm. All right, so I'm going to move into the second question. So being a college professor, what do your students actually work on, and how does this translate into industry and in real world experience or work experience?
So I get the pleasure of working with every single one of our biomedical engineering undergraduates throughout their junior and senior years. Their junior year, we really focus a lot on laboratory skills and scientific communication and teamwork, which is something that will affect anything that you want to do in your life, right? To be able to communicate things and avoid using jargon, and to be able to work with others in no matter what their work styles are super essential skills that can translate into industry, graduate school, whatever you want to do. In our senior year, my seniors do capstone design, and those students are working in teams that they have to stick with the same team throughout the academic year. And they come up with ideas and they develop medical devices over the course from September through May. So some teams in the past have built devices for cervical dilation, and we've had teams building monitoring systems for Parkinson's symptoms. We've had teams do things to measure UV light exposure. There's so many different cool projects that our students have done, and they continue to amaze me.
Mm-hmm. Yeah, so with these projects, I know you're saying they're starting to come up into these clinical phases if they actually stick through with it. How many of these projects have actually been working into development, if you were to say?
That's a great question. It's really hard with senior design projects because at the end of senior year of undergrad, the students are mostly all going on to their next venture of life. Some of them go to graduate school, medical school, they go into full-time jobs, and they're not all in New York City anymore. They're all scattered across the world. So most of the projects kind of end when they graduate, but there's been one in my 2 years so far teaching senior design. There's been one project that is continued to be worked on past the end of the project. They're still working on it. They're working with Columbia Technology Ventures, which is the department within Columbia that deals with intellectual property and patents. And they are working on continuing to develop their device and get a patent. And that's a device that can deliver automatic CPR chest compressions during cardiac arrest. So it's really cool when they decide to continue, but it's totally up to them if they want to do it. By the end of our course, the projects are still significantly far away from the point where we'd actually be able to bring them to market and use them as medical devices. Because as you'd imagine, there are a lot of legal guidelines and restraints to make sure that we don't hurt people.
Let's we take our final question.
So thank you so much. That was really interesting to hear about all these devices and opportunities for the students. I personally find that so fascinating. So I guess our final question of the night for you is that many students and young people are interested in getting involved in STEM. So what are some advice or opportunities that you think is important for students who are interested in this field and are just trying to start up or get in?
I think that's a really tough question, because at the end of the day, I just want students to follow what they're passionate about. If you're really interested in learning more, we are living in the internet age where there's so many opportunities online for you to learn. You can read books, you can watch YouTube videos. I learned so much from YouTube, still, I learn new techniques and I bring them into the classroom. But if you are really serious about a career in biomedical engineering or studying biomedical engineering or any STEM field, perhaps look for research opportunities in the summer. There are some programs throughout New York and beyond that will allow you to work in research labs at universities, and that will kind of get your toes wet and see what it might be like to be in those lines of work. But really, have fun with it. Don't do something just because it's a resume builder. Do something because it really excites you, and that will help guide what will excite you for the rest of your life.
Wow, those are some insightful words. I was so happy that I was able to work under you this summer, during the program. And I want to say thank you again for coming on this meeting. I really appreciate you, giving your insight or your 2 cents into how STEM is changing healthcare. And I wanted to just finally say thank you on behalf of the POBots and Sanvi.
Yes, thank you so much. We really agree with everything you said. And I think part of what you said is also what we're trying to do here as a team, making these videos every week and sending them out to our audience. I think that's the exact goal that we're trying to reach. Make sure that there's some way that everyone can learn something, even if it's just through a simple YouTube video. So I think you coming on here and talking to us and speaking with us on this topic was really great. Thank you so much for your time, and we really appreciate it.
Thank you so much for having me. It's always a pleasure talking with students and then kind of spreading the good word of biomedical engineering. So I wish you guys all the best, and I hope you have a great rest of your day.
Well, there you have it. STEM and its new tech and transforming healthcare in ways only we could have dreamed of a few years ago. And the best part is we still have all the power to be part of that change.
Thanks for joining us today. Keep exploring, keep learning, and stay tuned for our next episode.